The overall goal of this procedure is to produce large amounts of a high-titer influenza virus A in a cost-effective system. This is accomplished by first obtaining serum pathogen-free, freshly fertilized chicken eggs. In the second step, the eggs are infected with influenza virus via the allantoic route for 48 hours. The allantoic fluid, which contains the virus, is then harvested. And the virus is snap frozen in liquid nitrogen. Ultimately, plaque and hemagglutination assays can be performed to determine the influenza virus titer of the collected allantoic fluid.
Visual demonstration of this method is critical as the harvesting steps are very sensitive and require careful handling of the eggs and a good knowledge of their anatomy.
Before starting the procedure, obtain serum pathogen-free, freshly fertilized avian eggs from a suitable vendor. Immediately upon arrival, place the eggs in a humidified egg incubator with an automatic egg turner to rotate eggs regularly at 37 degrees Celsius and 55 to 60% humidity for 10 to 11 days. After 7 to 8 days of incubation, wearing 70% ethanol disinfected gloves, wipe an egg candler with the ethanol and transfer the eggs from the incubator into the empty egg cartons. Then turn off the lights and hold the large end of the eggs one at a time against the candler. If an egg is fertile, thin blood vessels leading to a bean-shaped embryo should be clearly visible. If the egg is unfertilized, a small blood spot with a visible egg yolk will be observed. Then discard the unfertilized eggs and return the viable one to the incubator. If the status of an egg cannot be confirmed, mark it for later observation. On day 10 or 11 post-fertilization and immediately before use, dilute an influenza virus stock to 1 × 10⁻³ to 10⁴ PFU per milliliter in sterile PBS supplemented with HEPEs and place it on ice. Then candle each egg again and eliminate any dead, immobile embryos. Next, remove 3 eggs from the incubator and arrange them in a separate holder with the air sacs up. Mark the airspace of the eggs with a permanent marker. Then wash the area above the airspace with 70% ethanol and transfer the eggs airspace up into an egg carton within a BSL-2 biosafety hood. Now use a sterile 18-gauge needle to punch a small hole in the shell over the air sac of each egg, taking care not to insert the needle too deeply to avoid stabbing the embryo or yolk. Then draw the diluted influenza virus into a sterile 1 ml syringe. Attach a 22-gauge needle and carefully advance the needle at a 45-degree angle into the allantoic cavity of the first egg. Inject 0.2 milliliters of the diluted virus into the egg, and then after injecting the other 2 eggs, discard the syringe and needle. Seal each hole with a drop of glue from a glue gun, taking care that glue does not leak inside the egg, and then place the eggs back into the incubator. After all of the eggs have been inoculated, incubate the infected eggs at 37 degrees Celsius and 60% humidity without turning for the optimal incubation time depending on the influenza virus type. At the end of the incubation period, chill the eggs for a minimum of 4 hours at 4 degrees Celsius to kill the embryo and constrict the blood vessels. When the eggs have been sufficiently chilled, transfer them to a biosafety hood in a firm holder and clean the egg surfaces with 70% ethanol. Then use sterile scissors to open the eggshell above the air sac of the first egg. Remove the shell around the air sac, taking care not to damage the chorioallantoic membrane. Then use sterile blunt forceps to open the chorioallantoic membrane and gently move aside the embryo and the yolk sac with a small spatula or spoon, taking care not to rupture the yolk. Next, using a 1 ml Eppendorf pipette, carefully collect the allantoic fluid, tilting the egg to the side to collect as much fluid as possible as necessary. Each egg should yield between 5 to 10 milliliters of slightly yellowish fluid. As each egg is harvested, pool the allantoic fluid in 50 ml plastic conical tubes on ice. When all the fluid has been collected, spin down the virus and transfer the clear fluid into a new 50 ml tube on ice. Finally, discard the eggs in a BSL-2 waste container and immediately aliquot the clarified allantoic fluid. Then snap freeze the virus in liquid nitrogen and place the frozen stalks in a -80°C freezer for long-term storage. Influenza virus infection causes a cytopathic effect that results in circular zones of lysed cells, or plaques, that form on a monolayer of cells. In this experiment, the plaques were visualized by staining the cells with crystal violet, and 65 plaques were counted in the well with the 1 × 10⁻12 dilution of virus. Because 500 microliters of diluted viral stock was cultured on the cells, in this experiment the final titer was 1.3 × 10⁻14 PFU per milliliter. The hemagglutination assay is a method for titering influenza virus based on the ability of the virus to attach to the surface of red blood cells. As observed, the viral suspension agglutinates the red blood cells, preventing the red blood cells from settling out of suspension. A clearly negative result was observed with the 2 to the -10th dilution of virus in 50 microliters. Therefore, the final titer is 2.1 × 10⁴ HAU per milliliter.
After watching this video, you should have a good understanding of how to propagate influenza virus by inoculating chicken eggs and harvesting the allantoic fluid containing the virus.